Hello everyone, welcome back to the channel. In the previous video, we have learned about the concept of flow direction and also have written a simple code which we can use to make our own flow direction maps. In the previous video, which is shown here on the right hand side, we have used the code to determine various performance metrics like RMSE, correlation, standard deviation, Nash circuit efficiency, and etc. In that video, we have discussed about what each of these parameter metrics are and how we can calculate them in Matlab. We have already provided the code of Matlab in that video. So in this video, as I'm working with Python now, I thought it's better to convert that Matlab code to Python so that we'll be able to use this in our Python in our future neural network models to be able to get the same performance metrics like RMSE and other indices. So in this video, I'll briefly show you the Python code which we have made from that Matlab code. That code will be put in the GitHub in the link so that you can use it for your own purposes. So we will go through the few lines to just see the formulae of these performance indices, and later in the coming videos we will develop our neural network models in Python and compare its results with the Matlab ones. If you see in the screen here, you can see the code which we have used to determine various parameter metrics while we were developing our neural network models in Matlab. If you have not yet seen those neural network models, you can have a look in the description below. So this code, which was previously developed by IHE Dell, which we used in our Matlab codes to be able to determine our parameter metrics. Now we are switching this to our Python so that we can develop our codes using Python as well and have various parameter metrics. So if we directly go there, you can see here, this is the code which I have written to be able to have the same parameter metric results which we are getting using Matlab in the previous code. So if we see here in the starting lines, we were telling that P is the predicted and T is the target values which we want from our code. So based on that, this code follows the same procedure as the previous code, with only the packages are being assigned differently because here we use NumPy to be able to calculate all these. So initially we determine if we are having a data or not in the starting lines, and then slowly we calculate the sum of square of errors, which is just the predicted minus the observed whole square, and we sum it up to get the sum of square of errors. And whereas this RMSE is the square root of sum of square of errors, so its root means square error. So in the same way we calculate standard deviation and also various other parameters like Nash circuit efficiency and most absolute errors, which we discussed in the parameters video, which I'll be pinning it up in the I bar also here. You can check from the duration of 6 minutes to the 12 minutes where I've talked about these parameter metrics. So in this way, we have developed this code using the simple formulas of each of these parameter indices. So to be able to say that it's working pretty well, what we'll do here is we'll use a simple data set, run both Matlab code and Python code to see are we getting the same parameter values or not. So to test this code, what we are doing is I've downloaded it, it's trusted of Sweden, Travel Basin in India, and you can see here T represents current day, whereas T plus 1 represents tomorrow's. So if you see the 87.9 is placed in the first row in the tomorrow's data. So what I'm generally doing is just assuming it that T is my observed data and T plus 1 is my predicted data, and I'm just using this code to be able to see what is the error value which is shown instead of developing a new model. So because this is a test results, I'm hoping that both give the same error parametric values so that I can say both the codes are working in a similar way. We can see here that gave us a lot of results of RMSE, correlation in RMSE and minimal. So even when in the video which I have told you earlier, which you have seen in the description as well, even in that video, after running our neural network models, we have used this code to give the predicted data and the testing data and see the results. And this is how we got the various parameter metrics. So if we try the same thing now in Python, for which we have already developed the code, if we go to PyCharm, and this is the test code which I have developed, and this is the data file which we imported the data from in Matlab. So if we just put predicted data as the first one and the testing data as the second one, and we use the code error predict comma t, which is what this is defined as here. This function is defined as error p comma t. So if we just run this code, we can see that in a few seconds we will get the results of various errors. You can see that RMSE and correlation and other errors are given. Here you see only 6 parameter metrics, because in the code when I'm saying it to return data, I'm saying only 6. You can include as many as you want to get as many parameter metrics. So now I've put here 6. So if we just compare this results with our Matlab results, if you see, we are getting the same results of RMSE, correlation, standard deviation. So this is how you can use the code which was developed in Matlab. Now we have converted it to Python, so can use this code when you are developing prediction models or forecasting models to be able to get all the results easily without having to use another formulas, etc. That's it for this video. If you have understood the concept, please give this video a like, subscribe to the channel, and share it with friends whom you think this can be useful.